And welcome to the video Comparing and Ordering Rational Numbers. The comparing and ordering of rational numbers is a comparison of a number's value to determine or distinguish if it is smaller, larger, or equivalent to other numbers that might be written in different forms. There are three main properties that we're going to illustrate on the number line as they are read. So let's get started. The first property states any negative number is always smaller than 0 or a positive number. When we look on our number line, we see that all of our negative numbers are before 0 or any other positive number. So that means the value of these numbers are smaller than the values that are to the right of them. Number 2 states the larger the negative number, the smaller its value. Well, when we look at our negative numbers, we see that as our negative numbers become larger, their value is becoming smaller because they're going further away from 0. So, the more further left you go, the smaller the value of your number. And the last property states, the smaller the negative number, the larger the value. So that means that as we see our negative numbers becoming smaller, their values are increasing because they're becoming closer to 0. So those are the properties of numbers when we are comparing them. Let's look at the number line. Now let's say that n will be any number that we'll choose on this number line. So if we choose -8, we can clearly see that n is smaller than the value of b, and the value of a, and the value of c. And we choose another value for n, let's say -2, we can clearly see that n is larger than b because now it's closer to 0 than b, but it's still less than a and c. And let's choose another one, let's say +3. Well, now we can clearly see that n is larger than b and a, but still smaller than c. And if we choose 10, then we know that n is now larger than all three other values. Comparing and ordering rational numbers. If we don't have a number line, then we must remember the process of ordering to help us compare and order rational numbers. The first is convert the numbers to decimal equivalent using division. Either horizontal or vertical division will do. And number 2, order by place value. That means to compare the place value of each number to determine which place value is larger, smaller, or equivalent, to determine which one goes first or second when you're comparing them from least to greatest or greatest to least. So let's look at an example. So number 1, we're going to convert all these numbers to decimal. Now, we have to keep in mind our properties. And one of our properties states that any negative number is always smaller than 0 or positive number. So the first thing I like to ask myself is, do I have any negative numbers? Well, let's see. Well, there's a negative number, -6/7. So this number is negative and all the other numbers are positive, so that automatically makes this the smallest number, -6/7. We're comparing this from least to greatest. So now let's turn all our numbers to decimal equivalents. Here we have 3%. Whenever we have a percent, we have to find this decimal. And if we don't see the decimal, it is always hiding behind the last digit, so our decimal is there. Now, the percent sign means to divide by 100, or you can simply move the decimal 2 places to the left. So, 1, 2. So our decimal is 0.03. Now we'll move on to the fraction. I'm going to use a vertical division, which means I'm going to leave the fraction as it is and put in the decimal point. And remember, when I don't see the decimal on the 7, it's behind the last digit. And then add a 0. I will do this for each fraction. So 9 goes into 70 7 times with a remainder of 7. And I'll do the same thing to the 4/11ths, decimal point, 0. 11 goes into 40 3 times with a remainder of 7. And 6 goes into 50 8 times with a remainder of 2. Now that I've converted all my numbers to decimal, I'm going to compare them by place value. So I'm order by place value and determine which number is larger or smaller by the same place value. So let's look at the tenths place. So we're only looking at the tenths place. I know this number says 0.03 or 300ths, but I'm only looking at the tenths place. So 0 tenths, 7 tenths, 3 tenths, 8 tenths, or 6 tenths. Which tenth is smallest? Well, that's correct. 0 tenths was the smallest tenths place. So we're going to keep doing this for all the other numbers. We're going to look at the tenths place. And if we couldn't decide with the tenths place, then we move to the hundredths place. So on this number, 7 tenths, 3 tenths, 8 tenths, or 6 tenths. Well, the smallest tenth here is 3 tenths. So this goes next. And we'll continue on. 7 tenths, 8 tenths, or 6 tenths. Remember, notice I didn't say, or I'm not looking at 672. I'm looking at only the place value of tenths. So, comparing these tenths, the 6 tenths is the smallest tenth. And I'll continue on. Is it 7 tenths or 8 tenths? Well, 7 tenths will be next, and then the last will have to be the 8 tenths. So, I just ordered this from least to greatest. Alright, so let's look on to our second problem. We're going to compare this from least to greatest as well. And remember, we have to keep in mind that if we have any negative number, it's always smaller than 0, or a positive number, or the larger the negative number, the smaller its value, or the smaller the negative number, the larger its value. So, try the problem below by yourself. Here's the solution to the problem below. Check your work and make sure we arrived at the same answer. Sometimes with comparing and ordering rational numbers, you'll see you'll have two negative signs on the same number. Don't get confused. This does not mean that the number is negative. Since it has two negative signs, remember, a negative divided by a negative is a positive answer. So this fraction is positive because it has two negative signs. Two negative signs makes a positive sign. If we have one negative sign, remember a negative number divided by a positive number is a negative answer. So this value here is negative. So can you spot a positive number and a negative number? Well, let's see. Is this number positive or negative? Correct. It is positive because it has two negative signs. The negative divided by a negative is a positive. Is this number negative or positive? Correct. Because a negative number divided by a positive number is a negative number. Let's try this one. Is this number positive or negative? Correct. Positive. So remember when you're comparing, not to be confused and believe that this is a negative number. Remember, a negative divided by a negative is a positive answer. So look at comparing these from, let's do greatest to least this time. So when we looked at this earlier, we said that the negative 4/7 was negative. So that makes this the least of the group. So we have 1, 2, 3, 4, 5. So this would be the fifth one. So let's turn everything else into decimals. So remember, this was a positive because a negative divided by a negative was a positive. So the decimal points behind the 7, because we didn't see it, we add a 0. And now it goes into 70 7 times with a remainder of 7. And the same thing on this. 11 goes into 60 5 times with a remainder of 5. And 6 goes into 50 8 times with a remainder of 2. And this is already in decimal form. So now we have to look at the same place value. So we're looking at tenths. So we have 7 tenths, 5 tenths, 8 tenths, and another 5 tenths. Well, the smallest tenth that we see is 5 tenths, but I can't determine if the remainder of 5 and 0.5 and the 6 in the hundredths place, which one's smaller. So I have to continue on with my division. So I'm going to add a 0 to my remainder. And now I'm going to say 11 goes into 50 4 times. And that gives me a remainder of 6. So now, instead of looking at the tenths place, I have to move up to the hundredths place. So looking at the hundredths place, I have 400s here and 600s here. Well, 400s is definitely smaller than 600s, so this will be smaller than that one. So now the greatest number up here that we see is 0.8, so that would be number 1. And then 0.7 would be 2, and we already determined that this was smaller than this number, so this is 3 and 4. So now we order this from greatest to least, numbers to decimal. So 0.0 and 8 goes into 50 6 times with a remainder of 2. And 0.0, so that 7 goes into 60 8 times with a remainder of 4. 0.70 and 15 goes into 70 4 times with a remainder of 10. And 10 goes into 70 7 times with a remainder of 0. Now, on our two negative numbers, which will be 7/15 and 80/100, the larger our negative number, the smaller it is. So we're looking for the smaller negative number, because that would be the greatest. 0.4, or 4 tenths, is smaller than 8 tenths. So that means that this number is larger than the other number. So this will be, in comparison to our negative numbers, this will be larger. So from greatest to largest, we're looking for the greatest positive, and the greatest positive number is 8 tenths. So this will be first. Next will be 7 tenths. This will be second. Third will be 6 tenths. Third, oh, give me had the. And then this is positive, so this is, and 5 tenths would be next, 4. Now, this is larger because it's smaller, closer to 0. So that's 5, and that's 6. Thank you for watching our video on comparing and ordering rational numbers.